going to talk about the Caesar cipher. So I'm Kanta K and let's get started. Alright, so by the end of this video, we will be able to crack this piece of code over here. So let's take a look at the brief history of the cipher. So the Caesar cipher was named after Julius Caesar, as you may have guessed. He was a Roman general and he used this kind of encryption to write his military commands so that if an enemy were to intercept it, they will have no idea what it means and it appears like complete gibberish. So let's take a look at how this encryption works. So here we got some letters, alright? And if we apply a shift of 3, for example, because Caesar applied a shift of 3. So first, the sender and the receiver needs to agree on a certain shift. So in this case, 3, alright? Then to shift 3, something like this happens. So now A equals D, B equals E, and C equals F. Let's take a look at this cipher mathematically so that we can get the formula. Alright, so first, to encrypt, we must change the letters into numbers. So for example, A equals 1, B equals 2, C equals 3, and so on. Alright, then let's say that alpha is the letter number, what we just done, and beta is the shift. So in the previous one, we applied the shift of 3. So for example, in that case, the beta equals 3. Alright, and the gamma is the encrypted letter number. So the letter number after it has been encrypted. Alright, so let's take a look at the formula. To encrypt, which the sender does, they take the letter number alpha, add the shift beta with a mod of 26, and they get gamma, the encrypted letter number. They send it, and then the receiver, they get the gamma, the encrypted letter number, and they subtract the shift which they agreed on, beta, also with a mod of 26, so that they can get alpha, the letter number. And there we go. They will do one, secret message, receive, and send type of thing with Caesar cipher. Alright, let's take a look at an example, which Caesar might have done communicating with his army. Alright, let's say that Caesar wants to say move half the army west for attack and the rest to the east for defense of the castle. Alright, and he applies a shift of 3. Alright, then it will become something like that. So really complete gibberish for the enemy. So N becomes R, O becomes T, V becomes A, and so on. To decrypt this message with Caesar's army or his receiver does, of course they subtract 3 from it. So R becomes M, and then T becomes T becomes O, and then A becomes V, and so on until they get the whole message to make sense. Alright, so you remember this piece of code I showed you at the beginning of this video. Now is the time we can crack it. So the Caesar cipher was very good and very effective in Caesar's time. Unfortunately, today it's a very bad idea to use Caesar cipher for encryption because many people know how to crack it. Alright? And actually it's very easy to crack it because 1. there is only 26 possible shifts that are possible, which means it is very easy to try all of them, and if a computer does it, they can do it like instantaneously. But there's also a more effective method called the frequency analysis, which we are going to try today. So let's compare the English letter frequency and the encrypted code letter frequency. So K was the most popular in the encrypted one, E was the most popular in the English one. So maybe K equals E, which would mean that the shift is 6. Let's test that. So -6 from every letter, and then voila! So we get a message that makes sense. It says, "Dear Cleopatra, I fell in love with you from Caesar." Nice, we cracked it, and it was a love message from Caesar. Anyway, thanks for watching. Make sure you crack a book so that you can crack other codes and be smart here. Alright, thank you.